What's the origin of the universe? What if the Big Bang was not the beginning? What if the universe was repeating itself? What if it was locked in a constant pattern of expansion and contraction? Watch this video to find out. I'm Majed Tafor and this is the El Dorado.
Remember that old saying that history repeats itself? That would be a laughable understatement when it comes to the universe. But according to a study released yesterday, this same old saying about history applies to the universe itself. It does repeat itself, constantly, every few trillion years or so. A trillion years may sound to you like a long time, but cosmically it's like tomorrow. The professor of physics and director of the Princeton Center for Theoretical Science Neil Turok has just come up with a new, yet very interesting theory. That the universe forms itself again and again in cycles. What this means is that we have to rethink the entire Big Bang theory and its accompanying concept of rapid inflation of the universe. In fact, this is a totally new understanding of the way space and time work. According to what's commonly known about the universe, the Big Bang happened about 14 billion years ago. In its early seconds, the laws of physics as we understand them didn't apply. All that would eventually become matter burst forth in a matter of seconds, first particles, like electrons and photons, and eventually neutrons and protons, the building blocks of our atoms. Early seeds of stars, planets, and galaxies expanded out from that momentous point in time and space. It spread in such a way that the universe became highly smooth. Smoothness, on an enormous scale, just means that things within the universe are relatively evenly distributed. That is, if you were to put a cube around one section of the universe, it wouldn't be much denser than another randomly placed cube. On a smaller scale, like between galaxies or within a solar system, matter is lumpy and filled with clusters. Physicists theorize that shortly after the Big Bang, something called inflation occurred. Essentially, what was once a tiny, packed-together universe expanded out rapidly in a fraction of a second, and it continues to expand today. Inflation is part of the current standard model of the universe, called the lambda-cold dark matter, LCDM, model. In LCDM, the shape of the universe's trajectory looks, in some depictions, like a funnel, its wide top growing and spreading further out over time. That's one interpretation. But there are others that have arisen out of the same bits of information that scientists can actually observe and measure in real life, that is, observational astronomy. Real-life information is crucial if scientists are to use models to make actual predictions about the future of our cosmos. But what do we know for sure? Theoretical astrophysics is all about educated guesses that are shaped by the few things we do know for certain. Something called the cosmic microwave background, CMB, contributes to a big part of that observable information. The CMB is made up of the traces of radiation left over from an early phase of the universe. Radio telescopes can pick it up, and then translate the waves into a heat map image of sorts. This image actually shows us how the contents of the universe were distributed about 400,000 years after the Big Bang, the earliest observable snapshot of a universe devoid of stars, solar systems, and galaxies. Everything was closer together and almost uniform, except for tiny fluctuations that became the matter-forming stars and galaxies. This image serves as evidence that the universe started packed together, and has expanded to where it is today. We also know that the universe continues to expand, and can even measure, to some degree, how fast it's doing so. The CMB also serves to confirm that an earlier version of the universe was very hot, and our era is much colder. But are there problems with our current model? According to cosmologists, a number of problems arise with the inflation model, which itself expanded and corrected previous models that arose from the Big Bang theory. The inflation model was supposed to explain why, for example, the universe appears so homogeneous on a huge scale without the same initial conditions. But there are so many possibilities that arise from an inflationary model that it makes the model itself less useful. Then there's the singularity problem. The inflation theory also gets stuck at the point before the Big Bang, because according to it, there is nothing before it. The fundamental philosophical problem with the Big Bang is, there's an after but there's not a before. Mathematically, the Big Bang looks like it came from an undefined state. This is referred to as singularity. So, what does the cyclic model prove? If true, it would solve some of the seemingly unsolvable problems of the Big Bang and inflation models. It allows cosmologists to go beyond the Big Bang, but without any kind of magical philosophical issues. Scientists have proposed a cyclic model that could work mathematically in a few ways. Its core principles are these. The Big Bang was not the beginning of time. There was a previous phase leading up to it, with multiple cycles of contraction and expansion that repeat indefinitely. And the key period defining the shape of our universe was right before the so-called Bang. So, instead of a beginning of time arising out of nothing, the cyclic model allows for a long period of time in the lead-up. It claims to fix the same problems as the inflationary theory did, but builds even further. For one thing, the existence of time before the Big Crunch removes the singularity problem, that undefined number. It also utilizes string theory and quantum fluctuations. The cyclic model would also account for dark energy, an unobservable force that scientists believe is behind the accelerating expansion of the universe. Is it beginning to sound like science fiction to you? I know it's hard to wrap your head around. But in the distant future, our solar system and galaxy will be engulfed by black holes, which eat up all the other mass in the universe, and then after an unimaginable amount of time, only black holes will exist. Eventually, only protons exist, which have no mass and therefore no energy or frequency. For now, no one can tell if the cyclical nature of the universe is right or wrong. But, at least, it puts us one step closer to making sense of time and space. I recall the words of P.C.W. Davis, a universe that came from nothing in the Big Bang will disappear into nothing in the Big Crunch, its glorious few zillion years of existence, not even a memory. Thank you for watching.